Hello there, I'm Dominic St-Pierre, and you're listening to Go Podcast. Today, I talk with John Arundel on Rust, actually. Hey, so let me start by reintroducing the fact that we have this Go Podcast channel on the Gophers Slack. So if you are, out there in the Gophers Slack, please join. We are a couple already there. The channel is fairly new, so I'm trying to build something. So I would like to ask some questions before I do some interviews and whatnot. So we could have some fun. I'm not the best one. I would admit at managing things like that. But yeah, trying to do something here to help the podcast. So today, we will talk about Rust. And why Rust? Well, I'm on the camp of people that just think that, learning new things is very, very helpful in anyone's journey to just getting better at programming. So that's all. That's nothing more than that. It's just, that I do enjoy some new learning. For me, Rust is always difficult. I never really passed this first initial effort that it requires to get started with. But yeah, John Arundel is talking about that. So on that, I will leave you with the interview. Hey, Gophers. So I am with John Arundel today. So thank you, John, for joining for the second time.
Well, thanks for having me back. Great to be here.
Yeah, we will have maybe a strange subject today. We will diverge a little bit on Rust because I've followed you lately on Twitter, and I was intrigued to see, wow, what's going on with John. There's so many Rust related content these days. So I reached out and can you talk a little bit what's going on at the moment?
Yeah, I have gone down a bit of a rabbit hole with Rust recently. Apparently that's coming across, right? Especially if you follow me on Twitter.
Oh, yeah, totally.
So this is, we normally talk about Go here, and that's fine. And I, apart from writing books on Go, as we talked about last time, I also teach Go. And more and more of my students started saying to me, hey, are you interested in Rust? Because it seems kind of cool. And they were learning Rust and asking me for help with it. And it's something that I've looked at in the past. I'm sure you have as well. What was your... did you sort of get seduced by Rust hype or...
Yes, I did. But I hit a wall pretty quickly if I'm completely honest. I did not pursue the amount of energy that I needed to just pass the. I would not say the hello world. It's not that, but just past the initial 1 week, 2 weeks. I got discouraged, to be frank.
Yeah, I had exactly the same experience. I'm sure everybody listening has if they've looked at Rust. I sort of bounced off it a couple of times. It's maybe the way to put it. I don't know about you, but I think Go really appeals to some people who they're computer geeks like me, and they love programming and different kinds of programming languages, and it has its own very charming nature, which you've talked about many times. But it also appeals to people who kind of just want to get stuff done, right? They don't want to become a PhD in compiler theory or something like this, or maybe don't even have a computer science background, but they need to write some code. You need to get some service running or write some command line tool or something. And Go is appealing to those people, right? Because it's a pretty small language, not much to learn, not too much syntax even.
Yes, I almost wondered at some point when I tried Rust myself, and I've been doing Go for a long time now, and I almost wonder and ask myself, is Go made me a little bit afraid of the unsimple languages out there? So I think it's a fair question to ask.
Yeah, it really is. I think I felt a bit the same in that I really like the aspect of Go that there's very little to it. You can learn it quite quickly. Of course, then it takes a lifetime to get good at writing software with it, but that's true of any language. Software is hard. It's, I think, just like you, I sort of felt maybe, has Go spoiled me for understanding complicated languages? I mean, there's a place for complicated languages too, right? C++ is still around, apparently. And I looked at it, and as I'm sure we've talked about before, what I often do in my mentoring and teaching sessions is just reading code with people and talking about it. That's a fantastic way to learn, isn't it?
Yes. So are you saying that it's a little bit easier to read Rust at first than to write a new program?
Yeah, and I think, we start with some of my students, we started doing some code reading in Rust in the same way that we do in Go. And I was pleasantly surprised because I sort of thought, well, I don't really know much about Rust, but we can kind of understand this. Mm-hmm. We read through a couple of things, random projects that we found. And we were sort of, even though we're a bit frightened by a lot of angle brackets and question marks and ampersands, nonetheless, we could still sort of make out roughly what was going on. In the same way that I guess any programmer can in any language, you can sort of see like, oh, this is a loop, this is a function. Bit confused about some of the more abstruse stuff that's happening, but never mind, you can get the overall sense of it. And I thought, this is encouraging, maybe I am smart enough to understand Rust, which would be great. And I think I just kind of got the bug and started looking into it a bit more and reading the Rust book and other people's books and reading more code, trying to write programs myself. And as you said, that's a lot harder, but sort of in a fun way, I think.
Right. Yeah. For me, another thing, other than the hard part, I think people is, all aware of, Rust is hard, but another problem that I had myself is I found myself, how can I say that? The kind of programs that Rust would be extremely good at, it's not something that I tend to write myself a lot.
Yeah, right.
So my question is more like, what are you doing at the beginning? Because at the beginning, well, if you learn a little bit like me, I like to write, some small CLI thing at first, maybe a cat program and things like that. Trying to replicate the GNU core utils sometimes.
Exactly.
So are you doing that as well in Rust? And once you get a little bit more experience, what are you building with Rust?
Right. Well, that's a great point. I mean, when I first learned Go, I was very enthusiastic about it. Say, Go is the greatest language ever. It's all you need. If you understand Go, that's it. You can write any program. It's Turing complete, so no problem. And people love to criticize Go on the internet, as you know. Gosh, do they love to criticize it. And people would say things like, Go is a bad language because it has garbage collection. Mm-hmm. So therefore it's not suitable for real-time applications or really high performance or anything where you need predictable latency. Operating systems, phone switches, things like that. And my killer response was, well, I'm not writing an operating system.
Yeah,
I'm not writing phone switches or spacecraft control software. Call me when I am writing that stuff. Sure, we'll talk about other languages, but for now, Go is good enough. And I'm still not writing operating systems, but I sort of feel like maybe I could now. With Rust, I agree, Go wouldn't be a good choice for that necessarily. And these things are very tribal, aren't they? So let's say this one thing that people who do Go often seem to be a bit triggered by mentions of Rust. Maybe they feel it's been too enthusiastically hyped. Perhaps people in the Rust community feel the same way about Go. I don't know. But there's some kind of feeling that these languages are sort of uncomfortably adjacent in some way, isn't there? That maybe they're butting into each other a little bit, or people can feel they're competing for developers or mindshare or something like that. I don't really think that's true, though. Actually, what I think, now that I know a bit about both of them, is that Rust and Go are a really perfect complement for one another.
Yeah, that's also my vision, but with very very limited experience in Rust. But yeah,
It's not something you often hear, is it?
No, no, exactly. But and I'm a huge a programming language fan. I mean, I did a small detour in 2018 in Elm. To be frank, that was my first functional programming experience. I enjoyed that so much.
Yeah, that's really cool.
Yeah. So that's a little bit a small aspect why I was attracted by Rust as well. I really enjoy Go, but we have to be frank that at some time there's a little bit of verbosity that can be expressed a little bit differently, with a different language, and Rust is, from what I can see, sometimes a little bit more expressive.
Yeah, I think it's in some ways Rust and Go like best friends in that there's certain things they both really care about, safety, correctness, performance, even for different values of the word performance. Mm-hmm. I don't know about you, but it seems to me like both Rust and Go in their designs are kind of a reaction to what's wrong with traditional languages. Let's, naming no names, but C++ is the one that everybody thinks of in this space, just because that language has got so big and has so many different ways of doing things, and there's so much stuff to learn, and there's also so many potential foot guns that you have to learn to avoid. Somebody who's been doing C++ professionally for 20 years won't make silly mistakes with memory and things like that, but if you have less experience than that, you might well do that. It feels really appealing to just think, well, couldn't the compiler know that stuff? Like if this pointer is nil, doesn't the compiler know that? Like, can't it prevent me from dereferencing that thing unsafely? Yeah, it really can.
Right. I wonder sometimes, and I'd like to know your opinion about that, because it's a little bit, I think, is what you are saying at the moment, is that do you think that it's very hard for companies that do have C++ code bases to get I don't know, maybe not junior developer, but just new developers knocking at their doors and saying, I never did C++ in my life, but it seems to be great. I'd like to know that. So do you think that this is really where Rust could live at some point? Because those companies at some point, if we draw a parallel with COBOL, for example, in Quebec, we still have a lot of financial institutions that are still running on COBOL, and I have talked with my my wife Hunt, and they just can't find new candidates to maintain the system, so they had to switch at some point. Do you see Rust being that for C++ potentially?
Yeah, I think so, perhaps. And I mean, despite what we said about Rust and Go having a lot of values in common, they do diverge sharply in terms of how they actually tackle that stuff, right? If you think the designers of Go said it's really slow to compile huge C++ code bases because of various things about C++ that you can't change. You can only speed up the compiler so much. So they said, what if we made the language very simple, easy to parse, easy to compile, no circular dependencies, things like that. So we can really build it fast. Maybe the compiled code doesn't run as fast as C code would, but often we don't care, right? In network applications, the speed of the code is not the bottleneck, it's the network probably, or latency of something else, devices, things like that. So where performance isn't absolutely critical, a small language that's easy to learn and easy to compile is absolutely perfect. And it's still memory safe. So the Rust folks kind of went the other way.
Yeah.
Like hugely. They just said, let's take C++, take out the unsafe things from it, or just make people, mark it inside an unsafe block. So you can still do everything in Rust that you can do in C. You just have to say, hey, I know this is unsafe. Like it's on me to make sure it's actually okay to do that. The compiler can't guarantee it for you. But when that's not the case, the compiler can help you a lot. And I suppose the downside of that is Rust is a pretty big language that has everything in. I think with Go, they took C and threw out everything that they could possibly throw out. And with Rust, they put everything in that they could put in.
Right.
And then they took some things out again because they decided that's not a bad idea. Actually, if you look at the history of Rust, it's really weird. I mean, it's changed so much over a decade or so. You used to have a garbage collector. Not anymore.
Really? Wow.
Yeah.
Oh.
Used to have all sorts of weird things. And so it's changed a lot, but another way to look at that is it's been extensively hacked on, refined, changed, and polished by some incredibly smart people for years and years and years. And now what we have is something pretty excellent. Certainly worth the time of any programmer to look at. I'm not saying it's for everyone, but certainly worth spending a few minutes looking into or playing around with, isn't it? And resisting that initial sort of bounce off because it's unfamiliar. I like to say Rust isn't difficult, it's just different, and that's sort of the point. If it wasn't different from what we already have, there'd be no point to it.
Yeah, sure. That's one aspect that seems to be worth it. I mean, at some point, if you continue and pursue this learning curve, at some point you do acquire a lot of background knowledge that you just don't really need to have with Go.
Yeah, and I think people who like programming, which I know includes you and me, and probably most people listening, in that we enjoy doing it for the fun of it, as well as it solves problems we have, or we can earn money doing it, and so forth. Those are great bonuses, of course, but it's also intellectual fun. So it's a creative activity. It's expressive. We like to figure out ways to solve problems and then try to express those in code. In Go, that can be sort of it can feel limiting because so few facilities in the language, and there's generally only one sensible way to do something in Go, which is good, especially if you have to teach it. But sometimes it feels a bit like, I would love to solve this in a functional way or something, and Go just doesn't suit itself to that particular pattern, or it becomes really awkward to do something in a certain way in Go, and you just think, the language is steering me away from this way of solving it. That's fine, very opinionated. But in Rust, it's very much up to you, and you sort of think you can do it this way or that way. You could use iterators or a functional style, or you can even do it with inline assembly language, whatever you like.
Right.
It has all the toys. And that's why I think people find it really fun. And from an advocacy point of view, they say, but the performance, the correctness, the memory safety. But what they're really thinking is, this is super fun.
Right. Have you noticed a big difference? So let's say, in Go, we do have data races and things like that. And concurrency, even though it's easy, it's still not very, very easy to do. And you can still shoot yourself in the foot in Go, even though, we all love channels and whatnot. But have you seen a huge difference with the Rust compiler that you said to yourself, it really noticed something that I did there, which might have gone into production or in runtime at some point in Go potentially. Is it that good that a copilot maybe, and not in the sense of the AI, but I mean, is it truly helpful?
Yeah, I think so. That's a great point. I mean, like I say, it's what I'm not saying is you should all stop doing Go right now.
No.
Take up Rust. It's not a zero-sum game. That's the point, isn't it? There are lots of languages for lots of tasks. Different people enjoy them. And that's fine. And you can know more than one thing. You can have more than one skill. In fact, that's a really good idea.
Right.
A monoculture is a bad thing, isn't it? Especially in the tech world where things change so quickly. It's good to have multiple strings to your bow. And also because different programming languages teach you different ways of thinking about problems. And this is sort of your point, isn't it? It's that a lot of the time, we're not particularly worried about performance. Computers are very fast. Compiled programs are very fast. Networks are relatively slow. What we want is a language that's easy to learn, relatively easy to understand. Programmers are cheap, to put it bluntly, and cheap to train. And that's great. So that actually covers, 70, 80% of use cases probably. But then there's the rest. Somebody actually needs to write system software, operating systems and whatnot. Embedded software, things like this. And you need a different kind of language for that. Like people do this with Go, but it's a bit awkward. So you need something in that space. And ideally it would be something that sort of shares Go's values about safety and correctness and things. And I think Rust is that. And one thing that's really different about Rust, not just the angle brackets sort of thing, that's a superficial level, but on a deep level, the way Rust thinks about data is just fundamentally different to basically every other language. In the sense that, why do we find Go appealing in some ways? One of them, I think, is it lets us forget that there's actually a physical machine involved. Mm-hmm. We don't have to know that this is x86 and there are certain assembler instructions available, whatever, the memory word has a certain size. We can ignore those details. We just say, let's abstract over those. Let's just say, I want to write a loop printing hello world or whatever it is. I want to deal in terms of strings and things like that. Don't want to worry about the machine details. And that's terrific, very valuable for programmers. On the other hand, some people say, but I want to, I want to get to the details of the machine because I want to use the machine to its maximum capacity. I want to access the special instructions that the CPU has, or I want to take advantage of packing data efficiently in memory or something like that. So Rust gives you that. It says, yeah, you can twiddle the bits and bytes to your heart's content. And the compiler will also produce very efficient machine code for you. You can use abstract things like iterators and they all just compile away. There's no function calls. It just compiles to the kind of tight assembler loop that somebody would write by hand. So that's very nice, but totally different approaches, of course. And one of the ways that Rust forces you to confront the fact that you have a real physical computer is you need to work with memory. Chucking data around in your program is not free, right? Somebody has to allocate that memory. That takes time. Memory allocators do things. That's complicated code. You have to have an allocator. You have to call allocate. You have to get some of that memory. Might not be available. The operating system has to manage virtual memory and so forth. You have to deallocate memory when you're done with it. All of that. Go lets you entirely forget about all of that stuff, pretty much, right? You're just like, I'll just declare some variable.
Yeah.
Which is fantastic. On the other hand, Rust says, well, hold on there, not so fast. Like, are you absolutely sure you want to allocate that memory? And also, are you going to hand out pointers to it willy-nilly to people? You're going to start some thread, hand a pointer to this data, and then you're going to mutate it yourself. What happens if you both try to mutate it at once? Or what if the other thread's writing to it while you're reading from it? Isn't something bad going to happen? Rust says, yeah, it absolutely will. And that is the kind of bug that we run into in Go all the time, isn't it? You can hardly write Go without running into null pointer panics.
Yeah.
Or to a lesser extent, data races and things like this. The problem is your program probably has data races. It's just you don't know about them because it's just silently doing the wrong thing.
Yeah.
The best case is that it panics. The worst case is it carries on and produces the wrong result.
Yeah.
In Rust, your program just doesn't compile. So that's encouraging. You don't run into that problem because the Rust compiler just says, look, if you had two mutable references to this thing live in different threads, you could have a data race. So I'm just not going to let you do that. That's not possible.
That's a huge benefit. How many? I mean, let's imagine. So when you were starting to discover Rust, how many of this new mental model you had to think about? Let's say you're building something. So usually in Go we structure our data. We do a couple of algorithmic things, and so like you said, we don't really think about the underlying memory, but. How many percentage of your brain is dedicated now to do what the garbage collector is doing?
Well, less and less over time because, yeah, at first it was brutal because I was just trying to do things in the same way that I would in a Go program or any language. Suppose you've got some string that maybe you read from a file, and then you want to pass it to some function to do some processing on that. What's actually happening under the hood there? Is that string being copied? Who knows? I mean, the thing is, it might be. It wouldn't in Go, but that's not obvious to people who don't know the semantics of function calls and things like this, or that strings are actually smart pointers. But in Rust, it's very explicit. If it's something that is cheaply copied, like an integer or whatever, sure, it'll just copy it. On the other hand, if it's something like a string that could potentially be a big allocation of memory and an unbounded time to copy that string, it just says, no, you need to be explicit now about whether you want me to clone that string or do you want to take a reference to it. Oh, you want a reference? Okay, well, is that a mutable reference or a read-only one? Like, just having immutable values is terrific, isn't it? Because most of the time in a program, that's what you want. And sadly, Go doesn't have that. That would be a great add-on. But Rust has this, and everything is immutable by default, and you have to opt in if you say, yeah, I want to mutate this thing. And if you hand out a mutable reference to someone, it automatically locks it for you. Somebody else sort of has the keys to it right now, if you like, and even you can't modify it yourself, even though you're the owner, because Rust says that might not be safe. Which is great, but on the other hand, that means almost every program you try to write in Rust first time around just doesn't compile, and you're like, why will it not accept this? This is obviously correct.
Yeah.
And the compiler says, no, maybe it's sound, maybe it's not, but I can't prove it, just by looking at the code, so therefore you have to do something else. So to answer your question, the compiler hasn't directly saved me from writing things like data races or memory safety bugs, because I just can't get close to that. I can't design the program that way. It doesn't work in Rust. I have to fundamentally rethink what I'm doing. What data do I have? Who owns it? How long does it live? When do I need to mutate it? When will it not be valid anymore? All of these kind of questions I suddenly have to answer. They existed in the Go program as well. It's just Go kind of punts on it and just says, whatever.
Right.
It'll be fine, right?
That's scary to hear, though.
Yeah, well, that's exactly the point, is that now when I come back to writing Go, I'm thinking about it in a slightly different way, thinking, would the Rust compiler accept this? No.
Wow.
Well, maybe I shouldn't be doing it. Interesting.
Are you, and you say at some point you have some errors and things like that, and you need to do something. Are beginners in Rust not relying way too much on copy to just, work around the compiler errors and things like that at first?
Well, I think...
the clone, I'm sorry, cloning things all over the place. Yeah.
No, that's right. I mean, a lot of times that is fine, but I think Rust fundamentally wants you to rethink your idea of just sort of freely passing data around, maybe copying it, giving out references to it, that kind of thing. It says that all sorts of subtle bugs can arise from this, that even the compiler can't always save you from. So maybe rethink that. Do you actually need the data to be structured in this way? Example is in the blackjack game that I'm writing in Rust, just for fun. There's a game object, makes sense, and the game has a deck that you deal the cards from. And so in the game, when you start the game, it deals cards to the player and the dealer. And maybe you ran out of cards. Like maybe there are no cards left in the deck. So what do you do? So I instinctively wanted to write it so that when the deck deals its last card, it automatically replaces itself with a fresh new deck. But you can't really do that in Rust because, somebody has a mutable reference to the game, which contains a mutable reference to the deck. And if you're inside a method that's mutating the game, it also wants to call a method on the deck that mutates it, and that just won't fly. You try all different ways to do it, and the compiler just won't let you do it any way around, and you think, maybe what I'm doing here actually doesn't make sense. And after a while, it does start to train your brain a bit to think about the problem a different way. And now that you have that new brain architecture that can solve problems differently, you can then apply it in any language.
Right. But that's what I was going to say. I mean, this is extremely valuable, I think.
Yeah, I think so. And it's also just the fact that there's a kind of a peer pressure about this, or lack of peer pressure, in that if other people in your language community don't seem particularly worried about potential problems, you tend to not worry about it either. You think, those guys are smart. If they're not worried about it, I shouldn't worry. In the Rust community, people really worry about these sort of things. I mean, that makes sense because they are writing software that controls vehicles, medical, radiotherapy machines, things where lives are at stake. They really don't want to have bugs in their programs, so they're worrying about these things. I've started to worry about them as well. 40 years of writing software or whatever, and I've suddenly started to think, what if I have a bug though? That could be really bad.
Interesting. Yeah. You talk about that, and I'm like super pumped now. Probably going to do something with, but at the same time, I mean, it seems just a couple of examples that you just gave. So, I mean, I'm doing web development. This is my bread and butter, and I know that there is web development in Rust, but those kind of things seems to be extremely interesting to me. Just working on different I don't know, systems and whatnot. But yes, how do you start? You were mentioning that your student were asking about Rust. So, what it's like to start in Rust for you? How do you approach not scaring them or letting them being discouraged? What would be a couple of tricks that we could pass here?
Yeah, that's a great question, and I think it really makes a difference where you're coming from in terms of what your first experience of Rust is. If you come from C++, you're probably like, this is easy.
Right.
Or if you're coming from something like Python or Ruby, there's a lot of weird things for you to grapple with just from the fact this is a compiled language. All of that. You'd have many of the same issues learning Go, wouldn't you? And I did. Perhaps you did too. But it seems like there's a lot of people going from Go to Rust. I'm not aware of anyone going the other way, but that doesn't mean there aren't. There probably are. It's just I've got one foot in both worlds, if you like. So what I see is people who already know Go thinking maybe it'd be a good idea to pick up Rust. From a career point of view, that might be a nice thing to have. And also just from a programming as fun perspective. This is a fun language with lots of toys, new ways of thinking about things. Let's learn it. This should be fun. And then bang, they run head on into a brick wall of angle brackets.
Right.
And also, you can read a paragraph of some learned article about Rust, and I just won't understand any of the words in it. And I'm just like, I don't know what any of that means. But the thing is, I can write Rust programs. So apparently it's not necessary to understand that stuff. I mean, if you like programming language theory and things like that, sure, great. If you're a functional programming fan and you like things like Haskell and, about higher order functions and higher kinded types and things like this, fantastic. Rust is a playground for you. But also for people who just like to write command line tools, like you said, I think the first thing I wrote was cat or grep or something.
Right,
And it turns out that's perfectly straightforward. So this is the thing, is that a lot of the Rust materials and books and tutorials that you see out there are sort of focused on it from this very academic-minded point of view, computer sciencey point of view. That makes sense, right? Because Rust is so cool from that perspective. That's naturally what they want to talk about. But what if you're someone who just says, look, I'm not a genius.
Yeah.
I'm also not dumb. In my own case, I'm an extremely average programmer. So I'm a good test case for this. Like, if I can understand Rust and write sensible programs, then anybody can. And it turns out I can, which is great.
Yeah.
So I think I'm starting to work towards figuring out a way of explaining Rust to people, because it's how I eventually explained it to myself. You know how it is, if you read some tutorials or something and you get stuck on something, that's something you don't understand, you try to read about it a few different ways, try out different experiments yourself, and suddenly something makes sense and you're like, oh, I see now. That's actually not very difficult. It just needed to be explained in the right words. And I'm starting to zero in on that. So I'm now writing a book, The Secrets of Rust Tools, available in early access, and people are liking it. And I think I'm trying to be very different from the other Rust books out there, of which there are many, some of them quite good. And the way in which my book is different, I think, in that it sort of doesn't assume that you already understand all of this complicated stuff. It just I'm aiming not to tell people about stuff that's not relevant to them yet, right? Like in Go, if someone doesn't need to know about pointers, you don't tell them about pointers until you need a pointer.
Right.
Because it's just going to be a whole load of complicated stuff that they're like, I don't understand that and I don't know why I need it. So I thought, how far could we get in a Rust book showing people how to write Rust programs with simple examples without introducing all sorts of complicated high-level CS concepts, right? And it turns out quite a long way. I think I'm up to chapter 6 now, and we still haven't used generics.
Nice.
So that's good, right? I mean, we secretly have, in a way, because you probably know in Rust, you can take a parameter which is sort of generic by saying impl.
Right.
Like if you want something like a writer that you can write to, you can say impl write. That's your parameter type. Now, really, that's just syntax sugar for the function being generic over some type T where T implements write. But you don't have to put the angle brackets, which is nice. So there's that. So we're sort of saying, let's just talk about the things in Rust that we need to. It turns out one of the first things we need to talk about is errors. Or that's the first thing that I usually talk about anyway, because if you write some command line program, you want to print a file or something, well, maybe the file doesn't exist. What do we do then? Or maybe you try to read from the file and there's an error reading from it. What are we going to do about that? In tutorials, you always just see unwrap, i.e. panic if there's any error. It's just like in your Go program, just saying if not equals nil, panic. Great. Yeah, sure, that works in a sense, but you wouldn't really want your program to be like that.
Yeah.
Because, these errors always happen, and users don't really want to see panic messages and stack traces and things. So what are you actually going to do? Probably return some error, try to print a friendly message to the user. Not just panicking, saying IO error, but saying, here's the file I was trying to read. Here's the problem I ran into trying to read it. Here's something you might like to try and do to fix the problem. Or you just used the program in the wrong way. Here's what you should type instead. So this story is much nicer in Rust than it is in Go. Much as I love Go, I've even written a book called For the Love of Go. So, I've got some form here. But Go makes error handling really explicit, which is terrific, and errors happen a lot. So good programs are mostly about error handling, I would argue. The happy path is easy. Anybody can write that. What do you do when something doesn't work as planned? That's the clever bit. But Rust has a lovely syntax sugar where you can just say question mark after some function that might fail, like read, and that automatically bails out of the function, returning the error type that the function returns, and then someone can handle it. But somebody has to handle it. That's the point. It's not just an exception that can bubble up to the top.
Right.
Because a function in which you can use question mark, it has a return type of result of something, meaning this could fail. There might not be a result. There might be some error explaining what went wrong. So in order to even access that value, you have to do something with it. You can't just say, okay, here's my result. You have to say, now, did that result succeed or not? and maybe what you do is just use question mark again to just say, well, if it didn't succeed, bubble it up to the person that called me and so forth. But ultimately it lands on someone's desk and they have to decide what to do, print the error or whatever. It just doesn't clutter up all the rest of your code with a lot of if not equals nil stuff, which is nice.
Yeah, this is something I'm hearing a lot. The result is also there in Elm and things like that. I mean, this is a nice way to pattern match after that and see, do I have the value that I was expecting or I need to handle the error. Once you start getting used to that, yes, it might be a little bit, I would not say painful, but let's say verbose to return to Go and have all the if block everywhere.
Yeah, that's a great point. That when I switch back to Go, what I really miss is I miss question mark, I miss results and options, which is sort of there may be data here or there may not. It may just be nothing. I also miss things. The fact that Rust is an expression language. So everything that you write ultimately evaluates to some value. And if that's the end of your function, that's the value it returns. Whereas in Go, it's a statement-based language. So you have to sort of do a bunch of imperative statements and then say, by the way, here's the value that I return. So in Rust, sometimes that means you can really elegantly express your computation. It's just your function is basically an expression. So it is kind of functional in that sense.
Right, yeah.
But that doesn't work for every problem, as you know. Sometimes you just need plain old imperative programs. You need to write a for loop or something. So you've got that choice in Rust. You can structure it either way around, whichever makes more sense.
Yeah, I would guess that it's there's a lot of recursion as well, preferably over looping and things like that.
Yeah, exactly. What really impresses me is how efficient the compiler is able to be, in the sense that, the promise of something like C++, zero cost abstractions, wasn't it? You can have things like classes and traits or generics or whatever, and yet somehow it compiles down to really efficient machine code and no runtime.
Yeah.
This is a good selling point over Go if you need one, isn't it? Is that Go has a large and complex runtime, which is fair. It does a lot. Go routines, dynamic memory management, garbage collection, all of this stuff. That's fantastic. But it also means that your Hello World program in Go compiles to about 5 meg.
Right.
In assembler, it would be a lot smaller than that. And in Rust, it's about the same size. Rust has literally no runtime anymore. It used to have, but they got rid of it. In fact, the one thing it does have is panic unwinding, and even that's optional. So that's very nice for embedded systems, really low memory systems, chips inside washing machines, car ECUs, that kind of thing.
Yeah. Very interesting. So you were mentioning that you were writing, you were at the chapter 6. So I would expect that you at some point you need to talk early about memory management in Rust in that book, right?
Yeah, sort of. I'm trying to avoid talking about it because I don't want people to feel like they're running into a brick wall of computer science. Even though, at a certain point, they'll hopefully think this stuff is fun and interesting and they'll learn more about it. And then it'll seem perfectly straightforward once they've actually applied these ideas. But if you just try to pile a whole load of theory on top of someone, often doesn't go well. So again, I'll bring this stuff in when it's necessary. One reason, for example, is when talking about string types. So in Go, it's nice and easy. You just have string. It's very appealing. In Rust, you also have string, but then you have some other strings. Yeah. So what are these? And again, Rust is surfacing this fact that actually there's a thing called heap memory. Again, this is something that experienced programmers take for granted, or they've just internalized this knowledge. So if you ask them how the heap works, they couldn't necessarily tell you, but nonetheless, they're using it all the time. Your program has a chunk of memory that it uses to allocate for things like variables and whatever. And if these things are just temporary within a function, then fine. You don't need expensive allocation. It can just be on the stack or whatever. That's cheap to allocate, cheap to throw away. But if you need to pass that data around from one point in the program to another, it needs to live for a while, then it needs to be something that's on the heap, and that means it needs to be allocated. You have a pointer, that pointer has a lifespan and so forth. And that's the string type in Rust. And you can also have a string where, it's not your string, it's somebody else's string that you just have a reference to. You have a slice of it or something. You just have a kind of a view onto that string. So you don't need to own it. You're just pointing into someone else's string. So that's great. So that's a stir or a string slice, as Rustaceans would say. And then there's also the fact that, in Rust, strings are UTF-8, just like in Go. Mm-hmm. So they're guaranteed to be valid Unicode. But what about strings that come from somewhere outside the Rust program, like from the operating system, command line arguments, names of files, contents of files? These are just random bytes that you found on the street. No one knows what they are. They could be UTF-8, could be anything. So Rust has an OS string type to say this is just a bunch of bytes, so we don't know what they represent. It may not be UTF-8. And a few other things. But in general, if you know about string and stir, that'll pretty much get you 90% of the way. So again, I'm not trying to overload people with too much stuff. I'm just saying, the idea is not let's learn about Rust by writing some toy programs. It's let's try to write some simple but potentially useful programs that resemble the kind of things you might really want to do. And we'll then see how much CS knowledge and theory do we need to bring in. Mm-hmm. How much of the big book of Rust do we need to understand in order to write this program? It turns out pleasantly little, right?
Really?
It's amazing what you can get away without knowing in Rust. As I say, there's huge chunks of it that I just don't know anything about, and yet somehow that seems to be fine. So a comment from Steve Klabnik on Lobsters that he said, I wrote the Rust book, and I've got 15 years experience programming in Rust, and I've only ever written a macro once. And that was actually just editing someone else's macro. So, it's easy to read tutorials or something and think, oh God, I don't understand macros, so therefore I'll never make it as a Rust programmer. Well, relax. You probably won't need to do that.
Interesting. Yeah, that's reassuring a little bit, I would say.
Yeah, also, I think it's very different from the Go world in the sense that Go is small, and if you read the standard library or the runtime code or even the compiler, it's relatively understandable. Mm-hmm. We've said this before. Yeah. And that's great. And you're writing the same sort of code in your own programs. It's a bit different in Rust in the sense that it is very powerful and complex code you can write doing really obscure and clever things. And people can do that in the standard library or the compiler. But you don't need to write that stuff. You can just consume the fruits of their labor. You can use their crate or whatever. And your program can be very simple and straightforward. It's just a variable. Here's a loop over a sequence. I'm printing something. You don't need to do anything clever yourself because you can use all of that stuff built by other people. So that's great.
And the ecosystem is growing great. I mean, you find a lot of library, I guess, that for everything that you would need to do.
Yeah, too many libraries, really. I mean, the problem also exists in the Go world, doesn't it? And here's another point where the two languages have a very different approach to things. Go wants to be a batteries included language, so it just says, look, you may never need to import some third-party library in Go. You can just do everything in the standard library. You've got crypto, you've got HTTP, you've got OS, all of this. Fantastic. Very useful because there's only one way to do stuff and you can just easily look it up. However, there are some caveats that come with this that we know about. For example, standard library has to be kind of carved in stone and unchanged forever. So what if it turns out some API doesn't really work that well in practice, or the world has changed in 10 years and people want to do things slightly differently? Well, tough, Sorry, you're stuck with the standard library we have, or even the language we have. You can add new things, but you can't necessarily change the old ones. And I think the Rust people saw this and said, let's be really careful about what we put in the standard library. Let's not put things in the standard library until we really know that this is the perfect API that we want for all time. John Jengset said something to the effect, the standard library is by definition that set of APIs that we're willing to commit to forever.
Interesting.
That's a pretty small set. And maybe even that is too large. So what's interesting in Rust is that things that used to be in the standard library have moved out. So, things that you'd expect to see in the standard library, perhaps time, rand,
Really?
things
Wow.
like this.
Okay.
Even regex, have moved out to be just regular third-party crates on crates.io that you can import and use. But you can use somebody else's random crate if you prefer that. Like there's a fast rand, which is not suitable for crypto, or you can use rand for the full-fat version. I think part of the philosophy behind this is if something is really good and it's just obviously the best solution in the ecosystem, then people will just use it. It gets a critical mass, and it has lots of people working on it and improving it and so forth. And maybe eventually it'll become so much de facto standard that it becomes a de jure standard, and we'll just move it in.
Yeah.
Or maybe not. It doesn't matter. The point is that people have the behavior they need. They don't care if it's in the standard library or not, as long as they can use it.
But wait. I mean, this this triggers me a little bit because I've been bitten by third-party dependencies a lot in my career. So I was a .NET developer, and this is something that I really enjoy about Go. And now what you are describing is scary because it. Well, from what I hear, it seems to be how they do that in the JavaScript ecosystem, where everything is basically a module that you are bringing. So I mean, is there not a danger there at some point?
Yeah, absolutely. I mean, the thing is, if you're using third-party crates, they can come from anywhere, they can be anything, they can contain bugs. This is true of standard library code as well, if you think about it. There can be bugs in that too. The only problem is really hard to fix them without changing the API. So the good thing about stuff being out there in the world is it's possible to change and evolve. The bad thing is it's possible for it to change and evolve. Yeah. This could break your build, and Go has some way of tackling this with the module system. Rust has a similar system in that, it has versioning and so forth. And if you depend on some specific version of a library, then that's just the version you use, and there's no reason for you to update unless you want to. And if you find that the update doesn't work, well, you don't have to. However, there are things, that are so widely depended on that changes to them, occasionally they have to make breaking changes. And so therefore then these breaking changes ripple through the whole ecosystem, or maybe a tidal wave is a better analogy. And it does cause big issues for people, not necessarily a disaster, but a fair amount of work involved in keeping up to date on these things. So I suppose, in Go, if they made a breaking change to some API or standard library, and it would then be Go 2.0, right?
Yeah.
And if you wanted to build your program against that, you would then have to handle all those breaking changes and so forth. But that just never happens. So that's just not a thing in the Go world. Whereas in the Rust world, it can be. But at least it's sort of opt-in,
Right.
You mentioned JavaScript, which is always a swear word. Context, isn't it? And nobody wants to end up in sort of NPM world.
Right.
Clearly, that is taking the idea a bit too far. But I think Rust is sort of striking a balance between saying everything is frozen in the standard library, forever and backwards compatible, and the other extreme is just a free-for-all, anything goes. I think they're sort of steering a route somewhere in the middle where they say, actually, this de facto set of really widely used crates are incredibly well maintained by super smart people, in many cases the same people working on the standard library. It's just they're sort of allowing themselves to occasionally change it. That's
right.
the only difference.
What's the mentality about the community about that? Are they prudent a little bit? Are they writing their own things and first before considering something that is not done by the core team of Rust and things like that? How is the situation there?
Yeah, I think it's less. We have these kind of discussions about Go, don't we? Where somebody says, "What web framework should I use for my web app?" And somebody says, "Oh, you shouldn't use any frameworks. Just use the standard library write it yourself. And they're like, yeah, but I don't really want to implement JWT from scratch or write my own auth or something like this.
Right.
What about, there's so much boilerplate in a web app, as you know, which is sort of just a solved problem. Wouldn't it be nice to just import that? And then all you have to write is the business logic about what's different about your
That's
app.
called Ruby on Rails, mister.
Yeah, exactly. Exactly. That's what people want, isn't it? They want Rails for Go, which is why Wales exist.
Right.
And you can talk to Lee Anthony about this. There's not really anything the equivalent for Rust, and I'm not totally sure why. There's a few videos or books that I've seen, for example, Luca Palmieri's Zero to Production in Rust, where he basically builds a standard-ish web app from scratch in Rust using just crates and things, mostly using the Axum framework. And he sort of says it's not that hard, right? It's easy for people to be sort of intimidated and terrified into thinking, I should just use some framework,
Right.
People who don't have a lot of experience writing programs, natural for them to feel, gosh, that's really complicated and I'm not smart enough to do that. Better to just import somebody else's code. When you're a bit more experienced with this stuff, you realize whatever you do, it ends up having bugs. Usually easier to fix your own bugs than somebody else's.
Yeah.
Also, you kind of get smarter as a result of having written that stuff, and then you know how to do it again next time, so it's not so scary.
Absolutely.
And I think maybe one reason why this doesn't quite exist in Rust world yet is just that people maybe aren't using Rust to write web apps too much, probably because it makes much more sense to do it in Rails or even Go with Buffalo or something like that.
Right.
And while you absolutely can do it in Rust, of course, and that stuff's fun to do, I don't know if it would be anybody's first choice.
No, right. Yeah, totally.
Perhaps that'll change.
And what about the async module or crate or whatever that you want to call it? So I mean, I'm hearing a lot of things there where concurrency does not seems to be as easy as in Go for sure.
Yeah, that's really interesting. So this is another place where there's really interesting differences, and it's not obviously the story in one language is way better than the other. So, concurrent programming is hard, as we all know if we've tried to do it. It's just difficult to mentally process lots of things potentially happening at once, and even sharing data and communicating with each other and so forth. So this is hard in any language, and you can have concurrency bugs and things, and the language can't prevent you from that, from having that. But it can give you some nice facilities to do stuff like Go routines and channels are fantastic primitives for writing concurrent programs, but pretty basic, For example, common thing in Go is to say, well, I'd like to start a bunch of Go routines, all computing some chunk of the data that I have to do, and then I'd like them to all line up their answers and reduce them back into one again, and I'll just print it. And also I need to wait for all of those Go routines. I need to handle any errors that happen if they terminate abnormally or something. How do I do that? Well, the answer is you just have to write that stuff yourself, and you can use wait groups and things. And in Rust, you don't have Go routines, but you sort of got two different tools you can throw at it. One is traditional threads, OS threads. A lot of times that's actually what you want. Think about something like an app where you're making, you're processing some incoming events. Maybe you've got one bit of code that just waits for events and reacts to them, and another one that's just updating the UI or something, drawing the GUI or the TUI. And two threads are fine for this because they're basically just two tasks. And they're long running. And you can do that in Rust as well. But you also have async tasks, which are a bit like Go routines, except really not. So this is the danger, is that you see this and think, gosh, that's just like a Go routine. And then you realize it's very different. For one thing, Go routines don't return anything.
Yeah.
They can't. I mean, where would they return to? The program's already moved on. You've got a go statement, and then it moves on to do something else. So there's no way you could return it to. In Rust, an async task can return something. In fact, it always does, even if it's just nothing. And so you have the choice. You can sort of start your async task and then just move on to do other things. And then at some other point in the program, you say, now I'm ready for that result from that async task. So I will now await it. Or you can say, I need that async thing to happen, and there's nothing I can do until I have that result. So I'll call the function and await it right now. There's no equivalent of that in Go. What you'd often like to do is await some Go routine, isn't it? But you don't have that.
Okay, so it's the same model as, JavaScript and C# for that matter. They do it. Yeah, okay. Interesting.
Yeah, with some subtle differences because, it has to be different. But basically that same sort of model. And Go, it really is totally different in this. And it just has its own thing, which isn't like any other language.
And do you have something similar? When someone is starting with Go, they kind of use concurrency everywhere, even though it might not be the right things to do. What would be the same things in the Rust world? Does that exist at all? Since you are saying that, the standard library is so tiny that I would not imagine that there is anything like that. Yeah.
Well, yeah, I mean, to your specific point, no, people do not try to do everything with async tasks in Rust because they just, that sounds really hard, It's interesting because it's sort of like one of these what color is your function problems, in Rust or in JavaScript, for example, you have fundamentally two different kinds of functions, async ones and non-async ones. And in Rust, you can't call an async function from a sync function. It's basically that your program is either async or it's not. So that's quite nice in a way, because most of us don't need to write async programs. So if you don't, you just don't need to know anything about that stuff. And if you do, then everything is async. So again, it's not that complicated because you're not bridging between those two worlds.
Interesting.
So I think it's, but certainly the underlying point of what you were implying, I think, is that it's sort of, once you get this wonderful hammer provided in the language, you start to see everything as a nail, and you think, I'll solve this with Go routines.
Yeah.
Now I have n problems for n Go routines, or n equals runtime.num CPUs. And in Rust, I think this problem doesn't quite exist so much because there's an absolutely wonderful crate that solves a lot of these problems called Rayon, which if you have some parallel task, like just chomping a big load of data, you can use Rayon, and as long as you can turn the thing into an iterator, you can just use pariter from Rayon, and that just takes care of automatically deciding how many worker tasks to run, how to parcel up the work between those workers, how to take care of new tasks that arrive, how to reduce all the results back in again, and how to take care of terminating the workers. And that just all happens by black magic behind the scenes. All you do is you just call pariter and then you get your result.
Nice.
So that is absolutely amazing. And if something like that existed for Go, that would really be a killer app.
Mm-hmm. Nice. Interesting. Well, John, I mean, this is, wow. I'm pumped. We'll probably look at your content because you're creating a lot of content. I read your Go versus Rust. For listeners, I mean, I encourage you to go check John's website. It's bitfieldconsulting.com. We will have all the links in the show notes. Do you have any closing thoughts? Anything that you want to mention before we wrap up?
Well, I think the phrase that I have in my mind when I'm thinking about this stuff is, the problem that people often run into with Go is that it's deceptively simple. Mm-hmm. And we've talked about this before, and that it sort of looks so straightforward. The code is easy to read. You think, well, it's easy to understand what's going on. But it's really not, because some very subtle things are going on. Subtle things are going on with pointers, with slices, with Go routines, with the runtime, with scheduling. You have to actually understand something about all this machinery in order to understand why your program is not working, which is why people sometimes complain about Go. With Rust, it's the opposite problem in the sense that the language is so big and the syntax is a bit intimidating. In order to kind of tunnel through that barrier, what you need to do is realize, hey, it's actually not that hard. Because 90% of it you just don't use, or you don't need to know about, or whatever. And the bit that you do need is completely straightforward, and it works just the same way that most other programming languages do. So the way I've summed it up is, with Go, you think you can understand Go code, but you really can't. Whereas with Rust, you think you can't understand Rust code, but you actually can.
Nice. I like that.
At least if you're willing to stick with it a little bit. Yeah. If you really look at it and you try to write some programs and you thoroughly bounce off it and you think, you know what, it's just not for me, that's okay.
Oh, yeah, totally. And I mean, I wanted to do this episode, not because I think Go is inferior and things like that. I also, like you mentioned earlier, I mean, just learning, just being curious, learning a couple of new languages, just seeing what's out there. I mean, it's very valuable for any programmers.
Yeah, you're so right. It's really important to keep on learning new stuff, even if you think you already know everything that you need to know for the rest of your career. Just from the point of view of the health of your brain, it is really valuable to expose it to new ways of thinking, new languages, and new tools. And learning Rust has lit up a load of brain cells that I don't think I've used in years.
Yeah. Oh, yeah. I can imagine. I would like that. I think because it seems to be great once you pass this famous X number of weeks. Seems to be great. Mm-hmm. Cool, John. Thank you very much for this. Maybe we can talk a little bit later. We will see. But yeah, if people want to check your course, we will have all the show notes. So it was great to have you.
Yeah. Thanks very much.
All right. Bye. All right, that's it for this week. I would really appreciate if you can talk or share about this podcast. It's always helpful. Also, another way to support this show is by purchasing my course. There's always a link in the show notes. So on that, see you next week.